stone dropped from a tower. A stone dropped from a tower is a freely falling body moving under constant acceleration I.e. acceleration due to gravity, 9.8 meters per second. A freely falling object is under the influence of the force of gravity alone, neglecting air resistance, and hence the motion of the object will be due to the acceleration due to gravity. Tennis ball thrown vertically upwards. A tennis ball thrown vertically upwards experiences a constant deceleration due to gravity. Deceleration is the negative of acceleration. This implies that the velocity of the ball decreases with time. The value of the constant deceleration due to gravity is 9.8 meters per second. This implies that the velocity of the ball, when it is thrown upwards, decreases at the rate of 9.8 meters per second. Water dripping from the nozzle of a shower. The water droplets dripping from the nozzle of a shower is equivalent to a freely falling particle or a particle falling from a height. The water droplets experience a constant acceleration due to gravity while dripping from the shower. A bag dropped from an aircraft. Aircraft flies at a certain height above the ground. A bag that is dropped from an aircraft experiences acceleration due to gravity till it reaches the ground. Hence, the bag is also a freely falling body. Ball rolling on an inclined plane. Neglecting friction between the ball and the inclined plane, the rolling ball experiences a component of the acceleration due to gravity, g sin x, where x is the angle of inclination of the plane. Hence the motion of the ball along the inclined plane is under the influence of constant acceleration. Merry-go-round. The horses on the merry-go-round rotate with constant acceleration known as centripetal acceleration. Centripetal acceleration is typically experienced by objects moving in a circular path with constant speed, but varying velocity. Such a motion is known as a uniform circular motion. The centripetal force is center-seeking and hence acceleration due to this force drives the objects, here, horse, towards the center. The following GIF depicts the accurate visual representation of uniform circular motion. The blue object revolving is equivalent to a horse on the merry-go-round. From the animation, we can infer that the rate of change of velocity is constant throughout the motion and the center-seeking acceleration is known as centripetal acceleration. Motion of Moon around the Earth. The revolution of the Moon around the Earth can be explained as uniform circular motion. Moon is under the influence of the force of gravity of the Earth and experiences a constant centripetal acceleration. A stone tied to a rope and swung in circles. When a stone is tied to the end of a rope and is swung in circles, the stone follows a circular path, and the motion of the stone can be termed as uniform circular motion. Assume here that the stone is swung with constant speed maintaining a uniform radius. The stone experiences a constant centripetal force due to which it has constant acceleration. Constant acceleration examples, frequently asked questions. Q. A body moves with constant speed. Can it accelerate? Yes, a body moving at a constant speed can have acceleration. Acceleration is the rate of change of velocity. Even if the speed is constant, velocity can change due to the change in direction of motion. The best suited example for such a motion is uniform circular motion. Q. Is it possible that the velocity and acceleration of a body can have opposite signs? Give an example. Velocity and acceleration are vector quantities. Hence they can be positive, negative, or zero. Yes, a body's velocity and acceleration can have opposite signs. For a body thrown upwards, velocity is positive, directed upwards, while the acceleration is negative, directed downwards. Acceleration due to gravity. Q. How does air resistance affect the motion of a freely falling object? We always consider the ideal case in describing the dynamics of a body. Similarly, in this context, we neglect the effect of air resistance. Here is why. For a freely falling object, the value of acceleration is 9.8 meters per second, i.e., acceleration due to gravity. If we do not neglect the effect of air resistance, acceleration throughout the motion varies and might fall less than the ideal value. That is because air resistance slows down the falling object. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.